Hey guys, welcome to your first video. We are going to be reviewing special right triangles from geometry, so if you don't remember them, it's okay, we're going to go over them again. So remember, if you didn't pick up one of those Cornell notes sheets in class today, you're going to go ahead and kind of set up your paper like this right here. So you're going to have that line across the top, you're going to put your title up here, and then you're going to write the essential question, which is how do I find the side lengths of 45, 45, 90 and 30, 60, 90 triangles. So that's going to go at the top. You're going to leave a little space over here about 1 to 2 inches, draw your line, and then at the bottom you're going to try to leave some space. So the notes that you are taking tonight are going to be right here, hopefully maybe closer to the lines. My finished notes ended up looking like this, just in case you were curious. And let's begin. So the first thing that we need to look at are those rules for those special right triangles. The first one we're going to look at is the 45, 45, 90 right triangle. And remember, that would also be called an isosceles right triangle. I hope I spelled that right. So when you have an isosceles triangle, you're going to have two sides that are the same. And then we know this is a right angle, FYI, and that means that these two angles are the same and they happen to be 45 degrees each. So if we were just using, regular Pythagorean theorem stuff, if this, for instance, was 1, this side was 1, this side would also be 1. We'd do 1 squared plus 1 squared equals c squared, and we'd find out that this side was root 2. Okay, we're going to kind of generalize that into more of a proportional type thing. And so any one side right here, if this was x, who cares what it is, this side would also be x, and that would mean that, remember, there's like an invisible 1 out there, that would be mean that this was x times the square root of 2. Well, I kind of just covered up the x. So we're going to make a little chart. I like this little chart. It helps me keep my thoughts organized. So we're going to have a 45, 45, 90 chart. As soon as I know that my triangle is a 45, 45, I'm going to go ahead and draw this. I'm going to write in my side lengths. So this would be x, x, x root 2. And if I know something about one of the side lengths, for instance, I knew that this was 1, I could fill in one of them, and then we could go and figure out what the other side lengths were based on that. Okay, so that's the first one, the isosceles right triangle. The next one that you guys covered in geometry was the 30, 60, 90 right triangle. So again, this is your right angle. One of your angles is going to be 30 degrees. The other one opposite it will be 60 degrees. And you remember this one back in the day. This side would have been 1. This side would have been the square root of 3. And this side would have been 2. Okay, so again, if we generalize that into whatever numbers we're going to need to use, this side would be x, the one would be x, this would be x times the square root of 3, and this guy would be 2x. Okay, so that kind of makes sense. Opposite the biggest angle, the 90 degree, is the biggest side, the 2. Opposite the smallest angle is the smallest side, so that's the 1, or just the x. Root 3 is in between 1 and 2, a little bit less than 2, so that means that it's opposite the middle angle. Okay, if I set up again my little cool chart, I would write 30, 60, 90, fill in the lengths that I know, which would be x is opposite the 30, x root 3 is opposite the 60, and 2x is opposite the 90. Okay, so again, this is kind of where we're starting. Let's go ahead and do a couple example problems. I got 5 example problems, so however you want to set up your page from here is up to you. Okay, so we're going to be example 1. Go ahead and draw in your right triangles. Pause if you need to. For example 1, we're going to find each side length, and they have told me that we have an isosceles triangle. That's what these little lines mean. These sides are equal, and one of those legs is 3. So I'm going to assume that's the right angle, shockingly enough. Okay, and so since I know it's isosceles, I know I can put in that this is 45, this is 45, and I can go ahead and draw my 45, 45, 90 chart. So I know that those proportions are x, x, and x root 2. And then I go ahead and fill in what I know. And so in this one, I know that opposite the 45-degree angle is 3. I also know that that one is 3 just by inference. And so now I know that I could fill in the rest of my chart. In this case, x equals 3. Pretty straightforward right there. So I can fill in wherever I see an x, I can put in a 3, and I know that this missing side would be 3 root 2. Okay, pretty straightforward. Let's try one of the 30, 60, 90 guys. So on example 2, they want me to solve for b. They've given me this picture. Again, we're gonna hate making assumptions, but this guy didn't give me a right angle in the corner. But we know that this angle is 30. So if you know that angle's 30, this guy must be 60. Therefore, we have a 30, 60, 90 triangle. Go ahead and fill in what you know. You know your x is opposite the 30. You know your x root 3 is opposite the 60. And you know 2x is opposite the 90. Go ahead and look at your picture, and you see that the number that we know is opposite the 90. So I'm going to go ahead and put a 5 under that guy. So this one's a little bit more tricky. They didn't just give you x right here. So using this is the one that I have the most information about. I'm going to go ahead and solve this guy for x. Well, if I could write. Okay, so when I solve that for x, it's going to just say 2x equals 5. This one is a pretty straightforward equation. I'm going to go ahead and, divide both sides by 2 and get that my answer for x is 5 over 2, or 2.5. For right now, it's probably going to be easier to leave it as an improper fraction, just for when we start dealing with radians. You're going to see a lot of improper fractions. Okay, so if I know that x is 5 over 2, I'm going, wherever I see an x, I'm going to put a 5 over 2 in. And then right here, for x, I can put a 5 over 2 times the square root of 3. And just for posterity's sake, I'm going to go ahead and call that 5 times the square root of 3 over 2. I'm running out of space, of course, just to make that look a little nicer. I look and see that the side that they wanted from me, b, is opposite the 60, so that guy is actually my answer. b equals 5 times the square root of 3 over 2. All right, next. Next one, example 3. We're going to look at this triangle, XYZ, and we need to find XZ, which is actually the hypotenuse of this guy. Now, looking at this, you say, cool, that's a 45-degree angle. I have one of the legs. Then that must mean that this guy is the same. Oh, and there's a root 2 in there. The answer is 5, right? Because there's a root 2 and it's a 45, 90 triangle. But you have to be really, really careful, because if this side was 5, this side is supposed to be the longest side, and 5 root 2 is actually longer than that. So you just made a not triangle. Okay? It should not be the biggest side. Hypotenuse is always the biggest side. So be careful on this one. Don't ever assume stuff. So we have a 45, 90 degree triangle, not just an angle. I'm going to go ahead and fill in what I know. Opposite the 45-degree angle is a 5 root 2. And then I can go ahead and take this and I can solve this guy for x. So if I have x, well, hold please. And so if I know right here this is 5 root 2, I already solved it for x. I'm struggling right now. So then right here I'm going to have 5 times the square root of 2 times the square root of 2. So when I am trying to simplify that down, since that's the side I want, opposite the 98-degree angle, we know that the square root of 2 times the square root of 2 is actually the square root of 4. And hopefully you know that the square root of 4 is just 2. So that means that that side length is just 10 units. Okay, and that makes sense. 10 is bigger than 5 times the square root of 2. Example 4, solve for y. Yay, I get a 30, 60, 90 triangle. So again, this is going to be your 30. And then I can set up my 30, 60, 90 chart. You're going to love this chart forever. Okay, again, this is what you got. Now you look and you see the side that I have is opposite the 60. So I'm going to plug that in and I have a 5. And now this one's actually not solved for x. So I'm going to go ahead and say x root 3 equals 5. So I can go ahead and get x by itself. Divide by the square root of 3. And I get 5 over the square root of 3. Now, contrary to popular belief, you were told before that you had to rationalize that denominator or get that square root out of the denominator. However, due to time, due to whatever, maybe if you made a mistake, I'm okay if you leave a square root in the denominator. Now you do need to recognize that if your answer was 5 root 3 over 3, that these two are equivalent. This guy and this guy are equivalent. However, this answer is perfect. That's all I need to see from you, 5 times the square root of 3. Okay? Make sure, though, if this wasn't an answer choice, that you could recognize it's the same thing. Okay, now the only thing here, too, is we're looking for y, which happens to be opposite the 90-degree angle, so make sure you plug it back in. I got a little bit ahead of myself there. So we're going to have 2 times 5 over the square root of 3. So the answer that I'm looking for, y equals 10 over the square root of 3, or if you wanted to rationalize that thing, it would be 10 root 3 over 3. Okay, again, you might need to know how to rationalize for an answer choice issue. However, I am perfectly okay if you leave a square root in the bottom. Last but not least, we'll call this our challenge question. Make sure you take a second to draw this thing, and if it's not perfect, oh well, make sure you draw your little right angle and whatever in there. So if BT equals 2 times the square root of 3, find the length of CT. I'm going to go ahead and write in what they gave me. BT is 2 times the square root of 3. And if I look at triangle ABT, I know that this is a 30, 60, 90 degree triangle. So I can write in 30, 60, 90, and I could go ahead and find all of those missing sides. Okay, so again, I have the one that's opposite the 60, and this is super convenient. You could set up this equation and say x root 3 equals 2 root 3 and then divide by the square root of 3, but then you'd find out that x is 2. So that means x is 2. 2 times 2 is 4. So if I go ahead and label what I have, we got this. That's nice and all, however, they want this guy. They want CT. So I'm going to have to go ahead and look at this thing, knowing what I have. I know an angle, I know a side. I know this is a 30 or 60 degree, so this guy's 30. And I'm going to set up another chart. Don't we love applications of this? So we have, again, it's still the same type of triangle, so I can set up the same proportions. Now I know the side opposite the 60 again, so I can take x root 3 equal to 4. Again, we're solving this guy for x. Divide by the square root of 3 on both sides, and I get x equals 4 over the square root of 3. And that's nice. Remember, you don't have to rationalize the denominator. Look what you're looking for. You want the side opposite the hypotenuse. So I'm going to go ahead and say 2 times that, kind of the same thing we saw in the last problem, and I'll get 8 over the square root of 3. Done. Again, that's the same thing as 8 root 3 over 3, should you want to make it that. However, I will accept anything that is not rationalized. And that is the end of your first day of video notes. How exciting. So remember, when you're done, kind of looks like this. If you use 2 pages, great, awesome. You put a little bit extra space in there. Don't worry about this column or this side. We'll talk about that in class tomorrow. And I hope you had a great first day of school.